Good morning, everybody. In last session, we talked about chapter 1, and in this session, we will start a series of 3 sessions on chapter 2. And in this first session, we will cover section 2.1 in chapter 2. And before we do that, I actually would like to thank you for participating in this course. And I see many of you post your idea regarding language and your past experience. It's very good that I can see a student from different backgrounds to join this course. And now I'd like to share my personal idea about programming language. So, regarding the question of which language is your best and most favorite language, and that is a question for you to think about yourself and which language actually you feel most comfortable. But actually, of course, there's no right or wrong or whose language is the best. We are not actually discussing that, but actually would like to share my own personal experience of how to learn programming language as a whole, and in general, can you develop yourself and into a professional programmer. So my suggestion is the following. Let me move this bar away. My personal suggestion is the following. First, you need to find a pilot language. What is a pilot language? In that language, you should train yourself to become full-stack programmer. The term full-stack means you can handle everything all by yourself. So basically, you're starting from basic programming idea, say C equivalent programming essential. From here is learn flowchart, pseudocode, and those basic computer science idea and structural programming. Second, you need to utilize that language to actually learn object-oriented programming ideas. And then you go into libraries, and then learn about GUI, file I/O, exception, numerical package, geometry, string, data collection, data structure, concurrent programming, and then event-driven programming, and networking, unit test, database, all kind of stuff here. And then you go into design framework for client-server model, for network, for app development. And this actually is a whole series of courses that you need to take. And usually in college, you have the Java 1 here, Java 2 here, maybe Java 3 or 4 in data structure, and then client server model, maybe 5 or 6 on app design. So it may take you 2 or 3 years to develop into this. And that's worth, at least one language, you need to develop your own skill in this direction and be a master for that language. And beyond that, in college, I personally think that you need to have at least Java, C, C++, Python, and maybe JavaScript. These are the 4 languages you probably need to pick up in college, and because these are all very important. And some students only focus on C, C++, some only focus on Python, and some do very well in JavaScript. But I personally believe that these 4 languages, at least you need to know all about them. And in terms of a starting language, I personally prefer this language Java as a starting language in high school. Especially we have AP Computer Science A in high school that's teaching Java. So, but before AP Computer Science A, you need to have at least half a year of training in programming, either Python, Java, it doesn't matter. But you get into CSA course, actually I would say should be CSA and B. CSA itself is not good enough. You need to learn second year or second semester college object-oriented programming. And that's actually a very fundamental and required training. And the reason why I pick Java as the pilot language is because it's easy to start from Java to either Python or CC++. But it will be very hard for you to start from Python and go back to directly to CC++. It will be difficult. But go to Java may be easy, and then you need to go from Java to CC++. Actually, it's not a direct route. And JavaScript is pretty independent. You need to learn JavaScript with HTML. That's a different story. But personally, I believe that you study from Java and in high school and got trained with the introduction to Java programming could be good enough. After AP Computer Science, you will move on to learn CC++, maybe in community college or in early lower division of college, and then you pick up Python 1, 2, 3 to complete yourself in one of the language in 4 steps. So that's about my personal idea about programming language. Now let's go back to chapter 2. Today I'm going to start discussing chapter 2, programming language syntax. In chapter 2, basically we cover 3 things. First, we cover syntax. Second, we cover scanner or lexical analyzer. Okay. Then part 3, we talk about parser. So in chapter 2, we cover these 3, and totally I will spend 3 sessions, 1.5 week. ION sessions on chapter 2. You know, some of the chapter I only spend one session, and some of the 2 sessions, but chapter 2 is the most important part for our course right here. Now let's get started. Overview of the programming language syntax. Formal language. This formal language is a computer term. And what is a language? A language designed for use in situations in which natural language is unsuitable, especially in math, logic, and computer programming. Now we say it's formal language. So the language is defined by symbols, formulas, and then precisely specifies syntactic and semantic relationship. So basically, it's a well-designed language that follows the syntactic rule, whatever it is, in very strict definition. And natural language cannot be defined like that. Natural language is developed by convention. And formal language is a logic system as well, and which interpretation is provided. So now we focus on this aspect, interpretation, how we interpret the language. And that's a key that we are going to talk about in our programming language. Basically, we have grammar as a syntactic. We have machine that will run for it, and then there is a language for people to do programming, follow the grammar, and then verified by the machine. So basically, a formal language is a set of rules, is a logistic system in combined. So here is a very clear idea of what a formal language can be used. And basically, we have 3 things right here. Number one is your language input. You write your program in a certain format. And then that language is defined by a certain set of grammar. And that grammar written down in this way, maybe BNF format, even EBNF format, maybe context-free grammar. Different kind of grammar, but this set of grammar need to be used for certain machine. Need to be defined for certain machine design. So a grammar being implemented as machine, finite state machine or state machine, and then your language patterns fit into that machine, and that machine verify the grammatical issue for you, and then validate those tokens, and then build a syntactic tree like this. So that set of program being defined, being recognized as a syntax tree like this, and then based on this syntax tree, we generate the target code. So here we have one thing, grammar, second, language, third, state machine. 3 in 1. That's the language development. And the whole thing we see here, including this over to the target code generation, this we call compiler. And programming language actually cover here. It actually is a whole set of knowledge to cover everything for you. That's a programming language. And in this chapter 2, we basically focus on grammar, state machine. And chapter 3, we verify the type. Chapter 4, we focus on this, the validated token and syntax tree. Chapter 5, we worry about the hardware issue, target machine code. That would be our first half of this course. So this chart is very important, help you to understand what programming programmatic is, and what is the parser, what is the scanner, the lexical analyzer, and what is syntax tree, and what is the target code. And for grammar, let's talk about grammar. Grammar defined by Chomsky, it actually has several levels. First, regular grammar, context-free grammar, context-sensitive grammar, recursive immutable grammar. So there is a whole hierarchy, and regular grammar is classified as the most restricted one. So the expressive power is the lowest. But in fact, whatever outside more flexible language cannot be represented by regular grammar as well, but it's more tedious to represent that. Just like any recursive language or recursive pattern can be represented by iterative algorithm as well, and nothing wrong. Maybe just not as efficient in expressing your idea, but actually they will be compatible. And these are the hierarchy of grammar. And if you feel interested in this topic, you can take the course in automata, or you can take course for computing models. Take some courses like this, but right here we are using it. We are not actually trying to give you the idea of how to design these automata and computing models. But that is beyond the scope of this course. So hierarchy of grammar, a context-free grammar is a grammar where the left-hand side of every production rule is a non-terminal, and the right-hand side can be a terminal or non-terminal. or the empty string. And the wider class of the grammar, that this is wider than regular grammar. And the difference for regular grammar and content-free grammar is recursive. You can put yourself on the right-hand side, but not for regular grammar. Chomsky described the content-free grammar as phrase structure grammar, while this formalism was originally developed for studying linguistics and natural languages. It has had a greater impact in the development of programming languages. So basically, we borrow a lot of grammar idea from linguistics, and computer language can be considered as a subset of the small subset of the natural languages. Here is a syntax for Arabic numerals. So here we try to define non-zero digit, and define natural numbers. And we know natural number is from 1 to infinity. So you may have 1, 2, 3, 4, 5, to 10, to over, to until infinity. But one by one, but there is no zero. So a natural number, if you put some symbol in there, the first symbol should be 1, 2, 3, 4, 5, up to 9. One of these, the first symbol, will be one of these. So let's do this. Let's consider, let's use this. Let's consider our first symbol would be 1 to 9. And the rest of them can be 0 to 9. But this one can be one time or even 0 times. But it can repeat itself. So this chart actually is the so-called SDD, syntax diagram for natural number. And this is one way to describe it. And SDD can find direct one-to-one mapping to regular expression. And later we'll talk about regular expression. But here we are talking about regular language. So basically we can try to describe this natural number as I say in this SDD format. So here we have a few symbols we would like to discuss. One is the clean star. So clean star is repetition. And then vertical bar, that's optional. And then alphabet. So 3 sin for regular language. So regular language over a alphabet sigma, and that sigma is alphabet. You know why we pick sigma? Because sigma is simple. That's Greek word, Greek capital letter. So it's one that contains either single string of that's 0 or 1, or string that can be obtained by using the operation of union, concatenation, and cleans repetition. So union and concatenation. So basically, regular language can only use the concatenation and union. Union is optional. Other than that, you don't have recursive expressive power. So they are basic operational intersection, complement, and difference. So these duo give you the formal language defined by regular language. The next one, content-free grammar. Content-free grammar has bigger express power, and it is a little bit more complicated. So here, Before I go into context-free grammar, I have to talk about what's useful for regular language. And regular language is useful usually for the design of lexical analyzer, or we call scanner in compiler stage. So this one, the function is basically you feed in a set of grammar defined by regular expression, and then you basically take in your tokens, that your file being tokenized into symbol by symbol, and then the scanner generate valid tokens for you. So actually, you take in symbol by symbol and then generate token for you. That's the function for this first stage lexical analyzer. And context-free grammar, on the other hand, it had more expressive power. So it actually have a grammar that has vertex, alphabet symbols, production rule, and starting symbols. And the language is defined as, that grammar is defined as any starting symbol that can, any state or symbol that can be generated by starting from the start state. So language L is context-free if there is a context-free grammar such that L is generated from that grammar. So basically, there is a grammar, and you can generate a whole language, any pattern based on that grammar. And grammar itself, written in certain formulation, can also be used as a checker for any language patterns. So that's the purpose for us to study regular language and context-free language, because we will look at context-free grammar and regular grammar. And that context-free grammar used for parsing. That convert tokens into syntax tree. While the first stage, regular grammar, used to validate your symbols into tokens. This stage we also call scanner or lexical analyzer. And this stage we call it parser. And these two are the first two stages in compiler. And that's the purpose of this chapter 2. So right here, we already introduced two sets of grammar. So the vertex is digital or non-digital natural numbers. And then alphabet used to define that vertex. And then you have the rule, production rule, and the starting symbol. So we have expression, grammar, and language. These three are actually related. So expression is a special pattern for the token of a language. So expression is contained by the language. So languages are all the compositional symbol sequence that's generated by the grammar. And the compositional symbol is generated according to that grammar. And the grammar can be used to validate the sequence. And those sequences, actually, we call it patterns, and we call it expressions. So these three terms are related. So regular expression is what you read down as the rule to define a regular language. So regular expression used to define or describe the language. And we use that regular grammar to build a DFA, deterministic finite automata, or non-deterministic finite automata, to validate the language or pattern. So, and also this regular grammar used to generate regular languages. That's the relationship between language expression and grammar. So here I give you a basic overview of using lex and yak. Lag is lexical analyzer. Yak is called yet another compiler. These two stages, one is used to generate a scanner, one is used to generate a parser. And you can formulate your language symbols in regular expression and then put it into a lex format called name.lex or sometimes name.l, and then feed into Frax program. And if you are interested in Frax and Python, you can check my past year 2017's LT1 videos. There are some videos for covering these two software. And these are used to generate some C code and then combine to generate a parser. And the parser actually is to validate your input pattern that is in simple format into tokens. So this one is the first stage lexical analyzer. I'm talking about how to use a regular expression to generate your lexical analyzer. And same thing, you can use content-free grammar written in special file format we call name.y file. You can call it yak files. And that yak file actually can fit into Python to translate to a C file, and that C file being included in the main program to become a YY parser. So this one use the content-free grammar that define over here, and then try to perform as a parser. So your C language or Java language can be fit over here. A program can be fit over here. And then here you can generate a interpreter format or machine code or even another high level language code. And this actually gives you the idea of how we are going to use our regular expression, regular language, content-free language for different purpose of in the compiler design and also in real world projects. So basically, anything you need to identify as tokens or IDs, you will need regular expression to generate the patterns. So any of the text file that's raw text file without processing can actually pass through the language regular expression check-in to generate special qualified tokens. And with that token, we can further translate it into certain parsing trees. So you can do some more detailed combination of tokens or token structures, analyze the token structure to understand what grammatical structure they have. So that's why this front end compiler design is very important, because it's very useful. It can be used for any software development as long as it takes some language program in and then validate it to generate some interpreter or some machine code or some compiler to help you to solve your problem. So it can be used for AI programs. It can be used for machine learning purpose. It can be used for compilers, or it can be used for any text-based programs. Very useful. So I try to teach this programming course in that direction, instead of giving you a lot of grammar that's hard to comprehend what it is. So why we started this? First, formally, we define a language using the formal language terms. So try to avoid ambiguity. utilize the tools for syntax design in general programming. So basically try to introduce the regular expression tool, lex tool, yak tool, help you to actually learn what's available to help you to generate some program in the shortest time to help you deal with syntax for certain input format. And that's one design compiler, but compiler is beyond the scope of this course. And it can be useful for software development, including tools, EDA, electronics, design automation, system automation, a lot of different projects. Even website can be related to this. The next one, objective. The chapter 2, we basically will cover the following things: regular expression, pattern matching, content-free grammar, flags, Python, syntax analysis, integration of all. And lesson Python this year, we will not go into detail to discuss it, but I do have a video of the last year. You can take a look on it. And then later I will introduce regular expression, pattern matching, and tokenization, SDD, syntax diagram, and also for regular expression checking. And this year I try to use Python language to cover this. And last year I used C, C++ to cover flags and Python. But because they already have a video for that, so this year I will focus on Python and deal with this topic. But if time permit, I may also cover finite state machine design for parsing using Python. But I don't know how much time I have since it is only a 8-week course. So now let's look at the regular expression and Baker's norm form. Finite automata. Finite automata, regular expression, grammar, and finite state machine. These are 3 in 1. 3 in 1 means what? You can have a regular expression written by this. It is equivalent to the grammar by this, and also equivalent to the machine that validate the pattern. It will be like this. 3 are actually equivalent. So simply 3 different formulations of the same thing. You write the same, you try to describe something in different formula. And there are algorithms to convert from one to the other directly. So formal definition of regular grammar. A regular grammar is a mathematical object G with 4 components, non-terminal, alphabet, production rule, and starting symbol. And so this actually just like this. You can have the non-empty set of non-terminal symbols. You have terminal symbols, and actually alphabet or symbols. And then you have your production rules and your starting symbol. And a regular expression is one of the following: a character, 2 empty string. A character, the empty string denoted by epsilon. 2 regular expressions can concatenate together. 2 regular expression can be separated by bar that also or mean or. A regular expression can be followed by clean star. So basically what does this say? Actually what it says is it can be a character 1. It can be an empty symbol. It can be any of the 2 concatenate together. And it can be any 2 that actually separated by bar that is actually optional item. So you can put serial coupled. You can put parallel coupled. Again, you can have the star to repeat it over and over again. Like this. This is called clean star. The reason why I write like this is that you may have none of them, so you go this way and here. You may have only one occurrence, you go this way. You may have multiple occurrence, you go this way and go back here, repeat. It's called clean start. Clean start actually means 0 to infinity and or 0 plus. And here I have to say, because of the clean start, we can have, because this clean start, we can have this clean start formation like this. This one is actually like, if this is A symbol, it can be A star, or you can be like this. This is called A plus. But you may argue like A plus will occur at least once, and it actually is not. It's actually not described by one of these. Then how comes that A plus is okay? It's actually a veritone, but actually it's quite simple. If you have this clean star, and then you add an A over here, these two are actually equivalent. So you can have A, or you can actually have, you can actually have this A star or A plus, and A plus is defined from A star. A star means 0 or more, for that symbol 0 or more, and A plus actually means 1 plus, 1 or more. And you might ask me, and if I don't like so many times, can I have only one time? Yes, you can have only one time. One time or less. You can write that is, you may have only occur once or 0 times. 0 or 1, you can write down as 0, 1, that is, for A symbol, happen 0 times or once. Or you can simply put A and the question mark. These are the regular expression. I'll discuss the regular expression later, but basically here is the syntax diagram. Here's the regular expression. But now let's continue. This is the regular expression. Basic definition of these: a character, the empty string, and you can have concatenation, that's a serial coupled regular expression, and then you have the vertical bar or that's parallel, and you can have repetition. So this one is a Becker's norm form for number, and you may see it like a little bit complicated, but let's look at this. Let's cut from here. Just focus on this part. If you focus on this part without watching, looking at the other side, you can have a sign or without sign. So basically, you can, if you have a number, you have a minus or no sign. And then second, you can have one single 0 and go over. That you can have a 0, minus 0, these kind of things. Or you can have a number starting with 1 and number of digits. So this side only for 0, and this side, this one actually is the natural numbers. So basically you have a sign, and then you, with that sign in front, you can have the sign, or without that sign, minus. And then go here, you can go 0 as a pass, or go integer as another pass, and then join together. That's the definition of the integers. And remember the natural number is defined as only 1 to 9, and then 0 to 9. That's natural number. and right here it actually been combined with a zero, single zero, and in front of it you can put a sign number. So these are the integers. After knowing about the integers, let's look at the right hand side, the fractional part, and then just forget about this part for exponential part. The fractional part is easy. You have a decimal point, or you may have no decimal point and go away. That's only the integer part. And if you have the fractional part, you can have a point and then have certain digit and then continue many times of them. That's your fractional number for decimals. And the last one is the scientific notation. To have a scientific notation, you can put an E in front of it, and later you have plus minus certain digit, or you can put an integer over here. That's actually finish this one. This one is actually a 14-point or double 14-point definition in regular expression for the 14-point numbers. So this one, numerical constant accepted by simple handheld calculator. So this one is beyond what we described for the 14-point number. It's actually a whole set of the numerical constant accepted by handheld calculator. So it's more detailed, and as you can see, this one is also still in regular expression format. You have a vertical bar, grouping by parentheses, and then you have concatenation, and basically these are the basic simple use over here, and actually this we call it the regular expressions. And if you check any one repeat itself, there's no. If there's a recursion, we call it content-free grammar already. But this one has no left-hand side calling itself on the right-hand side. So it's non-recursive. And since it is non-recursive and only use the vertical bar, the concatenation, and the clean star, so we call it regular grammar. So here are the more complicated term and factor, number, different non-terminals defined by the regular expression. Actually, I should say these are called syntax diagrams. So here we cover the syntax diagram for different IDs, different constants. So what is a regular expression? A regular expression is to describe a pattern of text, can test whether a string match the expression's pattern or not, and can use a regular regex. This one is short for regular expression, to search replace characters in a string. It's very powerful but tough to read. Okay, regular expression can occur in many places. It can be used in text editor. Say you have your Eclipse, and I'm sure there is some regular expression for pattern searching, and you can use that regular expression in JavaScript, and later we will discuss how to use that. And you can have the Unix grep set or find function that support a regular expression. So right here is a Ruby regular expression for the username at domain.qualifier. Actually, it's the .com sense. So The first part is the legal username, it's pattern. This one at is right here, and this is the domain name pattern, and then one dot, and then this is the qualifier. So look at the qualifier. Qualifier is lowercase symbol or uppercase symbol mixed together, and then at least the 2 symbol up to 4 symbol. So you can have that RU, Russia. You can have that .edu. You can have .com. And this part is a letter or digit. And then you can have dot or actually dash. I'm sorry, this dot actually is what? Is any letter. Okay, and a dash. And then plus is mean 1 or more. So you can have what? A.com or something. And why you have the backslash W and then dot? That is any symbol. Backslash W is any letter, but no like 1, 2, 3, no digits. And here is also leading with a letter, and then you can have that percentage sign, underline, and dash in your username. And backslash, and this the last backslash. This actually in Ruby is actually the start and the end of a regular expression. Same thing for JavaScript. And right here we have a regular expression simple table for it, and you can study the detail. The most important part is the qualifier. Let me see. Qualifier, how many times it is? You need to remember this: the star, clean star, and plus sign, and the question sign, and then specified by quantifier by 3, 4, 5, and then the character class. Character class, remember that if you have a lowercase s means white space, and capital S means the except, not white space. So be careful about character classes. And special anchor, cap sign for start of the line, and then at the end you have the dollar sign for the end of the line. And here are simple patterns that are commonly used for regular expression. So let's get started. So regular expression, you can find it in text editor. For example, you want to replace at least 1 or more space, you will take out those space. So basically, here are the symbols, and then you want to take rid of the leading spaces. So, and then you check regular expression, and then you hit that you will replace anything with starting spaces being taken away, and then actually that's the purpose for this. And then syntax of regular expressions. So the influence on tool and languages: Java basic syntax, many type and method names, scheme, first class function, closure, and dynamism, self, prototypal, inheritance, and Perl is on the regular expression. So for Perl, it actually is heavy on this regular expression because it is a scripting language. So here, talking about each different language main impact on the features, and Perl language is the one that makes the most impact on regular expression. So historically, Perl was a very horribly flawed and very useful scripting language. It's bad but useful. and based on Unix shell scripting and C that help lead to many other better languages. So from Perl, you have PHP, Python, Ruby, and Lua. Perl was excellent for string file text processing because it's built in regular expression. So basically, for these different languages, Perl make an impact on regular expression, and actually is built in with regular expression. The first one was that, and even in up to here, Java have some but very few built-in regular expression feature, and same thing for Python. It's actually an extra package called .re. Is actually you need to import RE package in Python in order to run or compile for regular expression. So regular expression regex methods, you can have match, replace, and search. Match is to match some pattern, and then you may return the index or the whole string for that match function. So return the first match, the first occurrence for the string against the regular expression. And usually it is actually giving you some index number or something in different languages. Right here, we use JavaScript as an example. Then you can replace the regular expression by certain occurrence, certain text format, text string. So replace the first occurrence of that. And if you use the /g format flag, you can replace for all occurrence. And this actually, if whether they implement the /g or not, it actually depends on different language. And some language like Java, they have the replace all function for string replacement. And then you have search, you have split. These are all allowing regular expressions. And basic regular expression. And you can just put ABC, that would be a pattern without any wildcard words. So ABC, ABCDF, DEF, ABC, and that equal that ABC, that equal that. These are regular expression. Actually, this ABC, these are the patterns that match ABC patterns. And it may be returned with a certain group and with some location, and this actually depends on different language. Python will return you the group in group format, and you have the group 0, 1, 2, and you can identify the location of each occurrence. And wildcard and anchors. A dot match any character is set precedence and the return. So that actually is any symbol. So dot O dot Y means doozy, goofy, loopy. And backslash that means what? It actually is mean a single character dot period character. That's a wildcard. And cap match the beginning of the line. $sign means the end of the line. Means that if you keep a cap in front of it, means that this if is actually only checking what? When it starts with if. And wildcard and anchor, slash angle or less than is the beginning of a word. Slash angle, right angle is the end of the word. So this specifies the certain pattern that need to happen at the beginning of a word or the end of a word. string.match regular expression, and you can say here, if a string fit the pattern, return the matched text, else null. For example, you can be used for Boolean trusty falsy test. If the name matching at least one lowercase letter, then you do something. So Obama match something one character with A, and then this one would return a bar and mar to occurrence. So this /G is global searching, not actually matching all. And I is after regularization means case insensitive. String replace, you can replace certain regular expression patterns with some text. So this one actually is for any S replaced by X, but this one actually have no G, so it's actually the first pattern. And this one with G that will replace all occurrence. But remember that this // is actually the is for what? It actually is the regular expressions starting and the end. And in other language, they may not use the // they may use simple string to use that. And in simple string, some of the language will, for a single backslash, will demand for two slash as a single slash. So be careful that different language will differ in the specification of the range patterns. So return the modified string as its result must be stored like this. So you must be remember that a lot of language, the string itself is actually immutable. So if you want to store the result, you must assign the result back to the reference variable. Otherwise, it will just generate the result and then never modify your original reference variable, and you may not be able to store the result. Special character. A vertical bar means or. So we have A, B, C, D, E, F, and /G. That means that A, B, C, D, E, F, or G. So currently we are page 32, and this whole set we have 55. We are on good pace. Okay, there is no end or symbol. Why not? Why not? Why there is no end symbol? Is there any logical operation in regular expression? Here we are not jumping the procedural call or the program counter for a program, and vertical bar is not making what logical selection. It actually is either way, because when we match pattern, if the first one doesn't match, we will try the second one. Both are branches. It's not if then else. So don't use the idea of if then else on here. So this vertical bar actually means you have two ways to define the pattern, and both ways will be tried when you do verification. It is not if then else something in regular programming language. So don't get confused by the regular the vertical bar, and there is no end symbol in regular expression. And parentheses mean grouping, and grouping is helping you to when you have the optional item, you definitely need to have a limitation of up to here. Otherwise, the vertical bar may go all the way. Then it doesn't make sense. So it's a certain grouping. And grouping has different other features. You need to take a look until the detailed grammars. And if time permit, I will teach you this grouping as well in a regular expression. But at this moment, we just up to here. And backslash start with a escape sequence. As I said, some special character like dot, you need that as a pattern, then you have to use a backslash. And for backslash n, if you want a backslash and then n, you need to have the backslash. And if you want to have backslash n, that may be what? That may have special meaning. That the backslash is actually has special meaning. So be careful for some character that these actually have definition in regular expression. So you need to use the escape sequence in regular expression. Some of them, like star or cap, is not a escape sequence in regular string, but for regular expression, they have special meaning for repetition or the start of the string. So you definitely need to have it as treated as a regular escape sequence item. So quantifier, you have star, as I say, is 0 or more, plus is 1 or more occurrence, and question mark is 0 or 1. So ABC star, that means AB, let me see, AB and 0C and 1C and 2C and many C. So this star only for this C. But if you have the grouping, then this star means BC for multiple times. And if you have a word in there, it actually can have a single letter or 0 letter or multiple letters. So plus sign means 1 or more occurrence. Question mark means 0 or more, 0 or 1 occurrence. And you may be using a specific quantifier like minimum and maximum. So right here we have A concatenated with BC, but BC may occur 2 times to 4 times. So it's A, BC, BC, or A, BC, 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 or A, BC, 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 BC. 3 different possible combinations. So 2 comma mean 2 more, 2 and more, 2 or more. Comma 6 is up to 6. Parentheses, the curly brace only 3, that exactly 3 times. Syntax of regular expressions. So character set is using the brackets, left right bracket. You can have left right bracket, that means optional. You can have B, C, or D as the starting symbol. So the relationship of the symbol right here would be the OR relationship. So any of these happen in front of ART, that will match the pattern. So this one is equivalent to this. So regular expression is not it can have a multiple way of writing a same pattern. And inside the bracket, most modifier key as normal characters. So be careful. Inside here is actually mean dot, exclamation mark, star, and question. So it actually mentions 10 patterns. But if you want that character be outside, and it will have special meaning unless you have to use the escape sequence. So character range, inside character set, specify a range of character with A to Z, that is lowercase letters, A to Z, 0 to 9, match any letter or digit. And this one also equal to \W. And an initial, A to Z, capital and lowercase, the combined equals /W, and A to Z, 0 to 9. This actually means the alphanumerical numbers. An initial cap inside a character set it as negation. So here we overuse this one, a cap. It no longer is different from the cap outside. The cap outside means at the beginning of the line. So inside a character set, minus must be escaped to be matched. And minus is used for the range specifier, so you can use the minus sign inside the character range. So built-in character range, \B means word boundary, and \big B means non-word boundary. \d means digits. \d means non-digit. /s means white space symbols. Capital S means non-white space symbols. \w means alphanumerical number and including the underline. And here is the Unicode for \x, HH, or \u, HHHH. These H are actually hexadecimal codes. Something like that. So pattern with G means global. That means the replace all or matching all. I means case insensitive. M means multiple line mode. And Y means sticky. Start with a given index. And flag can be combined. You can have multiple flags. Back reference. So when you capture that, you can use backslash number to say that the first occurrence of that, or the second pattern, second group, second capture. So these are more difficult in more details. Replacing with back reference. So you can actually like this. So you replace this first occurrence. So you want to replace some name matching this first group, and I use the second group. So basically, I can use a Tyler to replace Durden, and then Durden to replace Tyler. So you become something like this. And regular expression objects, we can do this. So here are the object. If we add the object, the purpose of this is later you can reuse the regular expression. Sometimes in some other language, it's not called object. It's actually called compiler, and compiler generate a object, and then later you can use that object to match other patterns in the future. So you can think about this as an agent. So we create an agent of certain regular expression that associate with certain regular expression. And this one may be a certain line of code. You actually do this regular expression for matching. And then 300 lines later, you do that regular expression again. So that object make the regular expression reusable. And then here is how to work with the regular expression objects. So basically, you compile the pattern and create an object, and later you use that object for different purpose. So here is the editor with the regular expression. And use grep operator with the regular expression. Now, let's look into the context-free grammar. A set of context-free grammar is not used for regular expression, not used for lexical analyzer or scanner. Context-free grammar will be used for parser. So this session we cover the regular expression and context-free grammar, and then the next section we will be using regular expression and context-free grammar for real world for the language compiler purpose. So the notation of context-free grammar is sometimes called a Becker's norm. And content-free grammar, including the terminal and non-terminal, and starting point symbol, and production rules. And the rule can have terminal and non-terminal. So basically, create a recursive environment, and the language called content-free language. So expression grammar with precedence and association. Regular expression work well for defining tokens. They are unable to specify nested constructs. So the arrow means that can have from or go to. So actually is a produce rule or reduction rules. Sometimes backward do this called reduction. That's when you pass the tree. So BNF and eBNF. BNF basically is based on the simple clean star, optional, and the concatenation rule. That's used for what? Used for the regular grammar. And content-free grammar use extended Becker's norm form, so it has more simple, more powerful, but actually it is describing the same thing as the original BNF. So each rule in CFG is known as a production. The symbol on the left are known as variable or non-terminals. In the programming language, the terminal of the content-free grammar are the language's tokens. One of the non-terminal, the one on the left side of the first production, is called start symbol. Every language has a starting symbol. Clean star is not used, and other regular expression is not used. And this is about the the clean star. And by clean star, we have different way of expressing it. So extended BNF. The BNF are similar to clean notation, but the extended BNF, it allows you to do the vertical bar, and actually you can combine this in one line, making it more robust and more compact. So deviation and parse tree. A content-free grammar shows us how to generate a syntactically valid string of terminals, beginning with the star symbol. The meta symbol is often pronounced as derived. So basically, the left-hand side derives the right-hand side. It indicates that the right-hand side was obtained by using a production rule to replace some non-terminal on the left-hand side. A series of replacement operations that shows how to derive a string of terminals from the star symbol is called derivation. So here is a grammar that generates a string slope times x equals slope times x plus intercept will be a line description. So basically this one is equal y equals mx plus b. That's slope and intercept form for a line. And to describe this form, we actually have an operator that times, and we have the plus sign and the times sign over there. So we have the ID times ID plus ID format. So basically you start from here to derive as this, and then this one quantified by this, and then this one by this, and then this one expand to here, and then this one be checked with that, and the last one, this one with the ID. So that's a derivation process. So the pass tree will be like this. If you pass the tree for slope plus ID by this, and this one is like left first. If you do left, you would end up with such a form. But if you do right first, it will become this. So there's ambiguity between two pass tree. But at this moment, we don't want to say which one is correct, which one is not correct. And later, we will discuss how to implement the precedence and which one has a higher priority. A better version that is not ambiguous will be defined by this. If we separate the operator by adder and the multiplier, the previous one has no difference. You only have operator, and operator group the plus sign and actually a minus sign over there. But this new set of grammar, you have 8 operator and you separate the ideal term and factor. Factor can only have the plus sign. Factor actually is part of the term. It's part of the term, and term is a bigger term. So term will have plus sign minus sign concatenated, while factor can only have division and multiplication. So by doing that, you actually will be able to pass this with the lab association and form such a pass tree. So here we finish the session 2.1, and here we focus on the introduction of the context-free grammar and the regular grammar, and also discuss the regular expression and context-free grammar. And we are going to use this knowledge to apply to our next 2 sessions on next week for the parser and the scanner, lexical analyzer. And for your part, if you see 2.1, there's a certain object to work on that actually is using Java as an example. I will say if you use Python using the RE package, I would accept that as homework. So don't worry, you can choose any language that support regular expression, C, C++, Java, or Python, or any other language that accept regular expression will be valid as an option for project 1. Okay. Now I will conclude. I will actually conclude this session. And let me know, because today there's no one show up for this session. So I will again process the tab of this video and then send you the link for the video from the YouTube. Okay. Anyway, thank you for watching the video, and let me know if there is anything I can help you on the section 2.1. Thank you. Bye now.